So I want to use this as an introduction into college algebra. Basically, I want this to kind of be a guide for overall ideas that you can expect to see in college algebra. As I know many of you may be coming into this just trying to get help on certain equations or maybe certain problems that seem to confuse you. And I'm hoping that I can at least give a little bit of insight into certain problems. So, as many people know, college algebra, it algebra starts kind of with the notion of bringing in free variables, aka variables like x or y, t, whatever it may be, to represent some type of number inside of a function. So when we do that, we can look at an equation, say like x plus 5 is equal to 12. So what we need to do here first is isolate the variable. So we isolate the x from, or we isolate the 5, sorry, from x. Cancel out the 5 to get 0 over here, plus x, which you can just kind of leave blank, but as an introduction. But then you do 12 minus 5, which is equal to 7, so this implies that x is equal to 7. Now, that is a simpler kind of problem where it's pretty straightforward and doesn't require you to do much more than that. Now, when you get into some of the more complex problems, we won't get too complex, but let's say we threw in a 5x plus, say, 17 is equal to 23. So when we do this here, we still isolate from the x. So we do everything not attached to the x first. So minus 17 on both sides. Because you basically just take the opposite operation of what is connecting whatever. I think the best way to describe it is just think of the opposite. So because this is an addition, plus 17, and we do the terms that are not connected to the x variable or the variable that you're trying to solve first, you just subtract. Now you do the opposite, so you subtract both sides, so you get 5x on this side is equal to 23 minus 17, which is 6. Then these two, x and y, or sorry, 5 and x, are connected by multiplication. It's one way to think about it. So since they're multiplied together, the only way to get them away from one another is to divide. So you divide by 5 on both sides, because 5 divided by 5 gives you 1, which 1 times x is just x. So then you're just left with x is equal to 6 over 5. So that's one type of equation that you can expect to see. There's different rules that come into when you're doing algebra and when you're solving some of these type of equations, because now we have to look at, let's say we have exponents in, and then we have to talk now about exponential rules. So let's say we have x squared times x to the 4th. This has a common base in x on both sides. So what we can do is combine these terms. Now, for some of you, you may already know this, but the formula for anything the same base, everything is equal to a. If it has the same base a, different exponents b and c, and they're multiplied, sorry, I wrote this wrong. If they're multiplied by one another, then you can add the exponents together if they're the same base. So x squared times x to the 4th is equal to x to the 6th. Same thing for x to the 5th times x to the 3rd is equal to x to the 8th. Also, same thing, if we do x to the 1 over 7th times x to the 2/3. Okay, looks weird, but all you have to do is 1 over 7 plus 2 over 3, which here, find the common denominator. So a quicker way to do this, in some cases, it does not always work. It helps if they're relatively prime to one another, which that's a whole different topic. But since these two are relatively prime to one another, you can just multiply the two numbers together to get the smallest base for the denominator. So to do this, you just do 7 times 3, which is 21. So you did 3 times 7 to get 21. So you put whatever you do to the denominator, you do to the numerator. Plus, also, now you did 3 times 7, so you times it by 7 to also get 21. So now you do 7 times 2, which is 14. So then you get 3 plus 14, which is 17 over 21. So then, coming back here, this shows that x to the 1 over 7 times x to the 2/3 is equal to x to the 17th over 21. That looks very ugly, and it looks kind of confusing, but honestly, it's still just the same thing, addition. And while you're not necessarily isolating the variable, once you get into equations where you have like terms or like a base, you can start to try to combine these together. Combine these bases together. Now you have to be mindful that they are one in multiplication and or division. Because if we have, for example, x squared plus x to the third, that does not equal x to the fifth, which I see people do a lot. The thing that you need to think about is what connects the two like terms. While you have x squared plus x to the third, these two have no relation to one another. While recording this, I wanted to add an extra note to say that these two have no relation because they are connected by addition. And this would be the same way as it is for subtraction as well, because they're different because the different exponents represents the differences in magnitude for each term. Therefore, they are not the same in addition and subtraction. But that's why in multiplication and division, they are, since exponents represent repeated multiplication or division, depending on the situation. When you imply this, you can say then x squared, if you had x squared plus 3x squared, that these two are equal, which would mean that this is 4x squared. That's okay, but not the other way. So, to continue on, say we have, let me write the rule back. So, same thing if we, I did it again, didn't I? Sorry. So, say if we have division now. So, if we had a to the b over a to the c, what does that equal? Well, usually, you can always kind of count on the fact that multiplication and division are opposite, therefore do the opposite thing. So literally all this means is that it's a b minus c. So if we had x squared divided by x to the third, we are left with x to the negative 1 because you're doing x2 minus 3. Same thing as if we just flipped it. It's at x3 over x squared. You get x because it's technically x to the 1, but yeah. Same thing if you got x to the third over x to the third. That is technically equal to x3 minus 3, which is equal to x to the 0, which is equal to 1, which makes sense because x to the third and x to the third are the same number, or the same notion, because technically you can import anything into the x, but we just usually use numbers. So now that that's understood, what we can do now is extend this to, say, a problem like, well, now that that's understood, how about now we go into combining into quadratic equations and or quadratic formulas. So like the FOIL method, for example. So another big thing that comes up a lot is equations such as x plus 5 times x plus 2. Okay. What is taught a lot is the FOIL method, which just means first, outer, inner, and last. So first, meaning the first terms in both of the properties. So this is the f. So x times x is equal to x squared. Because you're doing, again, x times x, which is equal to the same thing as saying x to the 1 times x to the 1, which is equal to x 1 plus 1, which means x to the squared. Just to relate it back. So now we have that first. Now we have outer, so the two outer terms. So you have x times 2, which they're still positive, so it's plus 2x. Inner, the two inner terms, to get plus 5x. And then you get, oh, sorry, that's not the inner. So that's the outer, that's the inner. And then we do, and I apologize for the jankiness, sorry. Now we do last. So you get 5 times 2. So 5 times 2 plus 10, since they're still positive. So now we can combine like terms. So x squared has no like terms. The 2x and the plus 5x have the same base, so we can add them together to get 7x plus 10. And that's your answer. So the thing you may notice is that technically you could distribute this in any way that you want, and you would still get the right answer. The thing about why the FOIL method is taught is because it puts them into descending order. And so you can know accurately that all your terms are laid out correctly, because usually when we write out our, not usually, anytime you're writing out your polynomial, you will be having to use it in descending order, because knowing the beginning order of your polynomial gives you a lot of information about the behavior of the graph without even looking at it. And that is something else that we can get into, maybe possibly in another video or in this one. But I just want to make that note as to why that is taught. And there's other reasons, just ease of access. It's an easier thing to learn, but that's overall the idea. Okay. Let's say if we extended this to possibly something not as difficult, but in the same idea of making like terms. So let's say we had 10x squared plus 21x minus 3 minus 24x squared minus 2x plus 10. Now, this is not multiplication connecting these two, but we do notice that these are in parentheses, and we have this multiplication symbol right here. Sorry. We have it right here. So because of that, what we need to do is we can just pull this down to still be like terms, or we're going to want to combine like terms, but I think something that's a good habit to have, just so that you know what you're working with, is to distribute that negative. Now, since this 24, which confuses a lot of people, since it has no sign in the beginning, it is a positive number. If it was negative, it would have this little negative sign right there, but it does not. Therefore, it is a positive number. So now distribute the negative. So you basically just do -1 times each of these terms inside of this parentheses. So -1 times 24 gives you minus 24x squared. Negative times another negative gives you a positive 2x. And a negative times a positive gives you a minus 10. So now we have our whole equation written out. So now what we can do is combine like terms. So now we have 10x squared with the same base as -24x squared. So we do 10 minus 24, which gives us -14, and the base stays the same, x squared. Now we do the same thing with the x's. So now we go 21x positive plus 2x, which gives us 23x. Then we have -3 minus 10, which -3 minus 10, it's -13, but I like to try to teach students sometimes. One, it's helpful to write it out, because I know that double negatives sometimes confuses people. If it also helps, think if you just multiplied this by, you can also just do the opposite and then revert it back. That also sometimes helps people, because sometimes thinking of -3 minus 10 seems confusing, because they still think of it as like addition in terms of 7. But then let's say if you times all this by negative, you would get 10 plus 3, which is equal to 13. And then just multiply it again by a negative to get negative 13. 10 plus 3 looks a lot easier than negative 3 minus 10. I would say that yes, you should probably try to get comfortable with this, but if you always want to have a sanity check, it is no problem. But if you divide times it by -1, make the signs opposite to make it an addition, and then revert it back. There's no problem with that. It's the same thing. Would take longer. Teacher may not like it, but if it's a sanity check. So yeah. So now we have this. There's technically other things that you could do with this. You could try to find the roots that, say if we had this equal to 0, you could try to find the roots with the quadratic formula would probably be your best friend here. Don't think you would want to try to do this by, the factoring method that you may have learned, which is also something we can get into another time. But I think overall, I just wanted to be able to show how to solve maybe not inequalities, but just to solve equations when it came to having unknowns. I can go further on this topic, but I think overall this would be a good stopping point. I guess let me know how you guys like. Hopefully you do. Hopefully it helps you. I will try to remain consistent with recording and giving and look at any feedback, if any, to try and give to people that could possibly help. Or if you want me to elaborate on certain topics as well, you can leave a comment down below. I will definitely try to get to that. And yeah, thank you guys. Hope you have a good one.